Flowchart math, fundamental theorem of algebra. Now we get into the hard ones. Okay, so look how complicated this one is. It kind of looks like a GCF, it kind of looks like a grouping, but none of that's going to work. And so we're going to have to do something else, something more complicated. Now, the beauty of this is it'll work for everything, but you might not want to use it for everything because it's kind of difficult sometimes. So anyway, here's what we're going to do. We have to look at the first two numbers and try to identify the different factors of the first coefficient. In this case, that would be 1 and 2, and the last coefficient. And in this case, it would be 1 and 12, 2 and 6, 3 and 4. Because what we have to do is we have to divide all of those green numbers by all of those red numbers. So the possible solutions or possible zeros for this polynomial would be the quotients of green over red. So what I'm going to do is I'm going to say plus or minus, and then I'm going to take all those green numbers, 1, 2, 3, 4, 6, and 12, and I'm going to divide by the red numbers. So divide by 1, and then do it again, 1, 2, 3, 4, 6, 12, and divide by 2. Cleaning this up a bit, we would have plus or minus 1, just reduce all the numbers, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. Then the second row, plus or minus 1/2. But then you would notice 2 over 2 reduces to 1, and I've already got that. 3/2. 4 over 2 reduces to 2, 6 over 2 reduces to 3, 12 over 2 reduces to 6. So I've got all those. Okay, now I haven't even factored yet. All I've done is said these are the possible zeros for the polynomial. So what I'm going to do here is I'm going to test them out and see if they actually work. I'm going to rip through this list and try to find a zero. And I'm going to use synthetic division to do that. Okay, so let's start with the first number in that purple list is positive 1. And what I'm going to do is look at the blue expression. That's my polynomial. It says 2x to the 4th and 5x to the 3rd and negative 11x squared, negative 20x plus 12. So write those coefficients, and we're going to go through the synthetic division process. All right, we're looking for a remainder of 0. Basically, that means that this number 1 works. So add down and multiply, and 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 add down is negative 12. Okay, we wanted this to be a 0. Since that's negative 12, not 0, then I know this does not work. Okay, so if that does not work, if 1 is not a 0, then that means x minus 1 is not a factor. So I can't look at that. All right, so let's try negative 1. That's the next number in my purple list. So this gets kind of tedious and people get kind of bored of it, but it is what it is, and we're going to do it. Once you get good at this, you can fly. So add straight down and multiply. When I say multiply diagonal, I'm multiplying by the number on the left. 2 times negative 1 is negative 2. Add down is 3 and multiply is negative 3. Add down negative 14 and multiply is 14. Add down negative 6, multiply is 6. Add down is 18. That one doesn't work. Okay, so let's try the next number in the list, positive 2. Add down and multiply. Add down and multiply. Add down and multiply. Add down and multiply. Add down and 0. Okay, 0. Sweet. What that means is if you divide, you're going to get a remainder of 0. That means that that number 2 divides evenly. Or if you think back to the factor, maybe I should talk about the factor, not the 0. That 0 value of positive 2 comes from a factor of x minus 2. That is one of the factors of my polynomial. Now, as a bonus, what I've done is I've reduced all of the terms in the polynomial down by a factor of x. It's like I've divided by x minus 2. So the new polynomial becomes 2x to the third plus 9x to the second plus 7x minus 6. Okay, so I've reduced my polynomial, and I want to continue factoring. So if you can do a different method, maybe you could do grouping or guess and check or something, you would do that, but I don't know another method here yet, so I'm going to continue with my fundamental theorem of algebra. So I'm going to try the next number in my purple list. The next number in my purple list was -2. Now, I'm not going to go back to the original polynomial. I'm going to use my reduced polynomial just because it'll be faster and the numbers are smaller. Okay? So you're doing the same process. Add down and multiply, add down and multiply, add down and multiply, and add down, and you get 0. Okay, great. That means this one works as well. So my 0 value of -2 must have come from a factor of x plus 2. And not only that, I've reduced my polynomial down by another power of x. So this just became 2x squared plus 5x minus 3. Now, you can continue going through this purple list, but most people don't want to as soon as they get it down to something that they know how to do using another method. If you look at 2x squared plus 5x minus 3, you might know how to factor this by a different method. To me, this looks like a hard trinomial. So remember, a hard trinomial is going to factor into something like this. And we take that -3 and we look for two numbers that are going to, let's see, multiply to -3, and they're also going to produce that 5. Okay, now keep in mind, they're not going to add up to 5 because one of them is getting multiplied by this 2. So let's think about how to do that. Yes, if I take 3 times 2, that's 6, and then subtract 1, that'll get me my 5, just like I need. So make sure you put the 3 over here in the position that gets multiplied by 2, and the -1 here, and you've got it factored. Okay, now we are finished. We've got a factor of this, x minus 2, and x plus 2, and 2 more factors here. Okay, remember what we're trying to do. We're trying to factor. So the answer is going to be 2x minus 1 times x minus 2 times x plus 2 times x plus 3. And it doesn't really matter what order you put them in, but most people will put the 2x in the front. It doesn't really matter.